Hello student, I am Tanmoy Majumder. In this video, I am going to discuss the most important parametric test of research methodology, that is T-test. T-test is also very much familiar with the name of student T-distribution. The theoretical work of T-distribution was first done by W.S. Gossett in 19th century. Gossett adopted the pen name student as published in finding under this name. Thereafter, the T-distribution is commonly called student's T-distribution or simply student distribution. We use T-distribution when population standard deviation is unknown and the sample size is less than equal to 30. However, if the sample size is greater than 30, then also we can apply the T-distribution. But generally, when the sample size is greater than 30, normal distribution is used because in those cases, the difference between the T and normal distribution is negligible. But if the sample size is less than 30, then normal distribution can't be used. Normally, t-test is based on t-distribution and is considered an appropriate test for judging the significance of a sample mean or for judging the significance of the difference between the means of two samples in case of small samples and when the population variance or the standard deviation is not known. Now, there are basically three main types of t-test. First one, a one sample t-test, where the mean of the single group against a known mean. Second one is an independent samples t-test, compares the means for two groups. And third one, a paired sample t-test compares the means from the same group at different times. Now I am going to discuss in details one sample t-test where the population is infinite, the sample size is small, and the variance or the standard deviations of the population is unknown and the mean is known. In such situation, the formula of the t-test will be t equal to x bar minus mu divided by s divided by root over n. Here x bar is the mean of a sample and mu is the actual hypothetical mean of the population. It means the population mean is mu. N is the sample size and S is the sample standard deviation. The formula of sample standard deviation is root over summation x minus x bar whole square divided by n minus 1. So student, here you should remember one thing, it is not the population standard deviation. As you know, the population standard deviation is denoting by sigma and the formula is root over summation x minus x bar whole square divided by n. But in case of the sample standard deviation, the formula is little bit of difference, that is root over summation x minus x bar whole square divided by n minus 1. Now the degrees of freedom. Degrees of freedom, here it is n minus 1. Now what is degrees of freedom? Degrees of freedom are the number of independent values that a statistical analysis can estimate. You can also think of it as the number of the values that are free to vary as you estimate the parameters. So typically we can say the degrees of freedoms is equal to the sample size minus the number of parameters we need to calculate during our analysis. Clear? Okay, let's do some math of this type. Okay, so here the math has given is manufacturer make a electric bulbs, claims that his bulbs have a mean life 25 months with standard deviation of 5 months. A random sample of 6 such bulbs gave in the following values. Life within bracket right in month has given 24, 26, 30, 20, 20, 18. Can you regard the producer's claims to be valid at 5% level of significance? And point number 2 is 1% level of significance. So see here, the mean has given, the mean life of the bulb is 25 months, that has given, and also it is a one sample test, as the life in month has given of a bulb, that is 24, 26, 30, 20, 20, 18. So it is a one sample test and mean has given. So definitely we should apply that formula, the t equal to mu minus x bar divided by s divided by root over n. Clear? Now you have to check the producer's claim to be valid at 5% level of significance. Here the degrees of freedom is given, that is 5. You know the degrees of freedom is actually n minus 1. N means the total number of observation. Here we see the total number of observation is 6, because we have taken the random sample of 6 bulbs. So 6 minus 1 becomes 5. So the degrees of freedom is 5. And you will have to check out the 5% level of significance. So the 5% level of significance, the t value has given, that is 2.571. And 1% level of significance, here the value has given, the tabulated value has given, that is 4.032. So in order to get the solutions of this sum, you will have to assume the null hypothesis. So here the null hypothesis will be, there is a no significant difference between the mean life of the bulbs in the sample and the mean life of the bulbs in the population. Obviously the alternative hypothesis will be, there is a significant difference between the mean life of the bulbs in the sample and the mean life of the bulbs in the population. So as it is a one sample t-test, so we should write down the formula of t. So t equal to x bar minus mu divided by s divided by root over n. T will be remain within a modulus sign, as because the value of the t will never become minus. Okay. So you know the x bar is equal to mean of the sample, and mu is actually hypothetical mean of the population, that is given is 25, and the n is equal to sample size, that is also given, that is 6, and the sample standard deviation, that is root over summation x minus x bar whole square divided by n minus 1. Okay, and the degrees of freedom, that is n minus 1, you know, 6 minus 1 equal to 5. So here in this math, you will have to judge the manufacturer claims is valid or not. Here the manufacturer claims is that the bulbs have a mean life of 25 months with standard deviation of 5. Whether that claims is valid or not, that we should prove. So for that we will have to take some sample. So definitely we will have to take some sample. So we have collected some sample where the 6 such bulbs randomly we have selected, and their life in month is given, that is 24, 26, 30, 20, 20 and 18. And we have selected that sample from the population. Here the population means from the manufacturing house. Clear? As we have selected sample to judge the producer claim, so here first we will have to find out the mean of the sample. So mean of the sample means the average life of the bulb in month which we have selected. So in the first column we have written down all the selected samples value, that is 24, 26, 30, 20, 20 and 18, and we have calculate the summation and we get 138. And you see the formula of mean you know already, x bar equal to summation x by n. So 138 divided by 6, as we have collected 6 samples. So here the number of observation is 6, means the value of n is 6. Clear? So we have got the sample mean is 23. It means the average life of a bulb in month is 23. The bulb which we have selected as a sample. Clear? Now in the second step we will have to find out the sample standard deviation. In order to find out the sample standard deviation, we will have to make another column of x minus x bar whole square. As you know, the sample standard deviations formula is root over summation x minus x bar whole square divided by n minus 1. So you will have to find out the summation x minus x bar whole square. So see, in the first case, x, the value of x is 24 and x bar equal to 23. So 24 minus 23 is 1, 1 whole square will 1. Second is 26 minus 23, that is 3, 3 whole square will 9. Then in a third row, 30 minus 23, that is 7, 7 whole square will 49. So such a way you will have to calculate x minus x bar whole square, and finally we will get summation x minus x bar whole square, means we will have to add all the corresponding value of x minus x bar whole square. So as we have got summation x minus x bar whole square, that is 102. So definitely we can easily find out the sample standard deviation. We know the formula of sample standard deviation, that is root over summation x minus x bar whole square divided by n minus 1. Now you just put the value in the formula. So summation x minus x bar whole square, the value is 102. So we can write 102 divided by n minus 1. We know n is 6 means the sample size is 6. So 6 minus 1 is 5. So root over 102 divided by 5. So ultimately we have got 4.52. So the sample standard deviation is 4.52. Now finally we will have to write down the formula of t distribution. The formula is modulus t equal to x bar minus mu divided by s divided by root over n. So the value of x bar is 23 and the value of mu, the population mean that has given in the math, that is 25 divided by s. S we have got 4.52, that is sample standard deviation, and divided by root over n. N we know the total number of observation, that is 6. And after calculating all this, we got the value of t is 1.084. Remember one thing, the value of t never become negative, so it is remains within modulus. So okay, the value of t is 1.084. So as you see, 23 minus 25 will minus 2, so minus 2 will be positive here. Okay, so finally you have got the value of calculated t. Now you will have to judge the manufacturer's claims is valid or not at the 5% level of significance and at the 1% level of significance, where the degrees of freedom is n minus 1, that is 6 minus 1 equal to 5. In that math it is given, and it is also given that at the 5% level of significance the value of t is 2.571 when the degrees of freedom is 5, and that 2.571 value of t is actually the tabulated t value, but our calculated value of t was 1.084. Since the calculated t is less than the tabulated t at 5% level of significance, so we can say the null hypothesis is accepted. So we can say there is a no significant difference between the mean life of the bulbs in the sample and the mean life of the bulbs in the population. It means the manufacturer's claim is valid. Similarly, the value of tabulated t at 1% level of significance has given in the math, that is 4.032, where the degrees of freedom is 5. So in that case we have also got the same results, as the calculated t value, that is 1.084, is less than the tabulated t at 1% level of significance, that is 4.032. So definitely we can say the null hypothesis will be accepted. So again we can say there is a no significance difference between the mean life of the bulb in the sample and the mean life of the bulb in the population. So the manufacturer's claim is valid. Clear? So I hope everybody understand the one sample t-test. So in my next video, I will going to discuss an independent sample t-test compares the means for two groups. It means the two independent sample will be there in that particular type of t-test. Clear?